today's episode, we're going to look at how to set up a TV with an Ambilight. Now, if you're not familiar with an Ambilight, this started with a Philips product of the same name that was available on certain select TVs that had this capability installed on them. What we're going to be doing today is adding a ring of LEDs around the back side of this TV to enhance our movie watching, TV watching, and video game playing. So this week, Halo Infinite's campaign dropped, and I've been super excited to go ahead and play it, and I wanted to enhance that by setting up the Ambilight on this TV here in my office. So let's go over what's required for this project, and then we'll jump into getting it installed. For this project, we're going to need a number of hardware devices to accomplish what we're setting out to do. Obviously, you're going to need a television and an HDMI source. But other than that, we have a few devices that we need to purchase so that we can set up this Ambilight. Now, of course, I have everything in a kit. If you want to go to this URL here below or go to the link in the description, it'll take you to a kit.co kit, which contains everything available from Amazon. Of course, these are affiliate links, so if you purchase anything off of this kit, it goes to support this channel. So the first thing we're going to need is a Raspberry Pi. Now, I'm going to be using a Raspberry Pi 4. I think you can do this with any version of Raspberry Pi. The problem is the processing power on board. The device has to have enough processing power to capture the video over USB and then be able to process the video input and turn it into the LED output. So I'm using a Raspberry Pi 4. Any version will work fine, though people have had success with a 3B. And of course, you're going to need an SD card and a power adapter. A 32GB SD card is more than enough for this project. Next up, you're going to need a USB capture device. Now, in this case, I'm just using one of the cheap Chinese ones you can find on Amazon for around 15 bucks, 20 bucks. And they'll work just fine because we're not really looking for quality. We're just pulling pixel data out. So we don't really need something super over the top, especially because it's gonna be connected to a Raspberry Pi. Now, they do have a number of USB capture devices that also have pass-through, which we're gonna need for this project, but I decided to use a splitter because it was more affordable. So that takes us into the next item we're gonna need, which is an HDMI splitter. So in my case, my Xbox Series X is 4K, and I don't have 120 frames per second TV, so 60 frames is more than enough. So I need to have a device that can at least pass through 4K 60 frames, which this device can. And this device also has the capability of downscaling the inputs. So in my case, I want the Xbox to come out in 4K, but I don't really want 4K coming out for the Raspberry Pi because the capture card can't handle it anyway. So I was able to downscale the 4K input to 1080p by using the switch right here on the device. And so now the Raspberry Pi is more than happy to capture that 1080p signal. The other bonus is this is able to be powered over USB, so I don't need another AC block plugged in behind my TV. Next up, we have the LED strips. So for this project, I've selected the WS2812Bs, which are 5-volt independently addressable LEDs. Now these come in different varieties. I've got the IP30 version, which is the non-waterproof version, because obviously if I have water being sprayed on the back of my TV, I'm in a lot bigger trouble than just worried about these LEDs. Plus, these are less expensive. They also come in 3 densities: 30 LEDs per meter, 60 LEDs per meter, or 120 LEDs per meter. In my case, I'm going with the 60 LEDs per meter to get a good density so I've got some color depth behind the TV. For this project, you could select any one you wanted, but I wanted to go a little over the top, so I went with the 60 LEDs. I wouldn't recommend the 120 LEDs because you're gonna need a giant power supply to drive those. And so on that subject, you're gonna need a power supply to drive your LEDs. Now, in this case, I've got a 100-watt power supply because these are 5-volt, 100 watts. It's kind of a large power supply, but I have a fairly large TV in here, so I'm just gonna connect it to the back so I don't have to worry about it. So to calculate the power requirements for your LEDs, we're assuming each LED consumes 0.06 amps or 60 milliamps. So then we multiply that by the number of LEDs we have. So if I were to use every LED on that strip, that would be 300 LEDs. So 300 LEDs times 0.06 equals 18 amps of current draw. So then we multiply that by 5 and we get our output, which is around 90 watts. So I selected a 100-watt power supply to make sure I have ample overhead. We're not gonna be driving every LED at 100% on white, so we don't need to worry about using all of our power available, but I like to have a little bit of overhead just in case. So because these power supplies don't come with an AC adapter, I just took a standard PC power cord, cut the end off to create flying leads, so that I'm gonna attach those to the power supply. So on the subject of other accessories that you're gonna need, obviously you're gonna need enough HDMI cables to interconnect all these devices together. So in my case, I have an HDMI cable going from the Xbox to the splitter, and then I have 2 HDMI cables coming out of the splitter, one to the Pi, one to the TV. So you need 3 total for this project. So finally, you're gonna need something that can interconnect the pigtail coming off the back of the LEDs with the Raspberry Pi. So you could buy some of these DuPont connectors inexpensively off of Amazon. You're only gonna really need one female to female that you can then cut in half and solder in to the pigtail. We only need 2 pins off this pigtail, one being the green, which is the data line, and the other being the black, which is the ground. So you can take a single cable, cut it in half, solder the ends, and then be able to use the other ends to plug onto the Raspberry Pi pinout. All right, with those requirements out of the way, let's get the TV taken off the wall and get started on the project. All right, before we jump into this project, let's go ahead and take a look at a rudimentary wiring diagram that I have here. So let's start with the power supply. So this is the power supply that we talked about in the last step. We got it connected to the positive and negative DC side. It connects into the 5-volt and ground into the LED strip. In addition, we have the data line and ground line connected into the Raspberry Pi. So utilizing the pigtail that comes with the LED strip, we don't need the red line at all. You do not want to connect the red line to the Raspberry Pi because you could blow it up. So what you should do is connect the green and white, in my case, being the data and ground. So you connect the ground to any ground on the Raspberry Pi pinout itself. So in my case, I've got my ground connected to pin 6, but you could connect it to any of the other grounds on the Raspberry Pi. I have my data line connected to pin 12, which is GPIO 18. Now this is the PWM pin for the Raspberry Pi. So we simply just need to connect those 2 pins on the Raspberry Pi, and then that's it for the data interconnect. Now, talking about the actual video capture, everything moves to this HDMI splitter that I purchased. So I've got my Xbox Series X connected to the input of the splitter, and then output 1, which is set in 4K, goes to the TV. Output 2, set in 1080p, goes through the video capture device, connected over USB to the Raspberry Pi. Now, I did notice, as I did this project, that my long LED strips go from being a bright white down to being a warm white at the end. And this is being caused because of voltage drop along the long strip. So in addition, if you have an extra long strip and you're starting to get some color issues, you can go ahead and connect the power and negative line to this end, to the other end of the LED strip, to be able to power both ends to get a more constant power through the entire strip. All right, so obviously, first thing you need to do is take the TV off the wall. This is something you need to be extremely careful with because these TVs are very fragile. Their screens can be cracked very easily. So I recommend getting help if you need it to pull it off the wall. Once you have it off the wall, make sure you set it on a soft surface. In my case, it's on this bed here, but if you don't have one available, then lay down some towels and make sure it's a flat surface so the screen does not get flexed or broken. All right, so the first component I recommend testing is the power supply. So we need to go ahead and connect it to the AC flying leads, and then connect that to power, and then we can test to see if everything is outputting like we want to. So we've connected the 2 AC points, and we see the LED is on, indicating there's power to the unit. So let's go ahead and grab our multimeter, make sure we're in voltage mode, and we're in AC. So the first thing we need to check is make sure we have good line voltage coming in, which we have 123 volts coming in, so that's good. So then we'll change this to DC mode, and we're going to try over 2 of these terminals here, verify we're getting good output. And it looks like we're getting a little bit over 5 volts, 5.28 volts, which is good. That's more than enough volts. Gives us a little bit extra for some voltage drop as well. All right, so now let's go ahead and turn off the power here, and we're going to take our LED strips, and let's go ahead and grab our wire strippers here and strip off just enough, make a good connection. We will loosen a couple of the lugs here. Make sure we've got positive, which is red, and negative, which is white. And so now if we zoom in close here, you'll see we've got our AC side with a good ground, and then we've got our DC side over here. We can flip the cover back down again. And now we'll test the power. So we're gonna go ahead and reapply power. Everything looks good there. Of course, our LEDs don't light up because we don't have any control over them right yet. All right, so let's take our pigtail that we received with the LEDs, and we're gonna go ahead and strip the white and the green. So we need a little bit more, get good contact there. Now for the wiring for the Raspberry Pi, I recommend taking some of these DuPont connectors that you can get pretty inexpensively off Amazon, and then just cutting one of the female and female ones in half, and then soldering an extension cable in between. Then you can take one of the butt splices and splice it into the pigtail that came with the LED strip. Now for the fun part. So let's go ahead and pull the adhesive cover off the back of the LED strips, and then we'll go ahead and place them along the back of the TV. Now please make sure you note where you want to start the LED strips. I typically like to do this in one of the corners, because this is where you're going to need to interconnect the power supply and the Raspberry Pi to it. Now when it comes to corners, you have a couple of options. One, you can cut and splice the LEDs using solder, or some of the variety of LED connectors that are out there. I've listed some in the kit. But what I like to do is cheat. I just push two of the blank PCB sections together and make a nice clean 90. Now continue doing this around the edge of the TV. Please note, make sure you have a clean surface to start with so these LEDs adhere and stay adhered. Continue to do this around the outside edge of the TV until you get back to where you started. At this point, make sure the LEDs can cross each other without having any of the LEDs being blocked by wiring. When you find the point where the LEDs want to end, get a pair of scissors or a pair of snippers and make a clean cut along the open contacts. Once you're done, I like to go ahead and check to make sure none of the LED strip has popped up. Confirm you have a nice clean fit throughout the rest of the strips on the TV. Now, because of the location of my power supply versus where the end of the LED strip was, I decided to go ahead and extend the wires using some scrap wire I had lying around. Instead of dealing with the trouble of soldering these together, I went ahead and used some butt splices that I had. You're going to get these from your local hardware store or auto parts store. Now, before putting the TV back on the wall, I went ahead and used some double-sided sticky tape to adhere the power supply and other devices to the back of the TV. My Raspberry Pi, I went ahead and used some sticky Velcro that I had lying around so that way I can pull it off the TV if necessary. Now, with a little cable management provided by some zip ties and some sticky back holders, the back of the TV looks decent. Now, the power supplies are a little bit messy, but other than that, it will work and keep the cables out of the way of the LEDs. Now, all there's left to do is to hang the TV back on the wall, connect power, and then jump onto the computer and configure Hyperion. All right, so the quickest and easiest way to set up Hyperion is to go ahead and install the pre-built version called Hyperion. Now, to do this, go to the URL below, and it'll take you to the Hyperion website. It'll take you to the website, so you can download the zip file containing the image to install manually. So first thing we need to do is unzip the download file and get the .img file out. Then we can select it inside of the Raspberry Pi imager. So let's go ahead and open up our Raspberry Pi imager. Instead of selecting one of the pre-made images, we need to install a manual image. After locating the correct image, we need to select it and load it into the Raspberry Pi imager. Then we need to select our destination storage. And then finally, before we go ahead and write the SD card, hit Ctrl-Shift-X to bring up the advanced menu. Go ahead and set the host name for the new device. Go ahead and enable SSH and set a password. And then go ahead and configure the Wi-Fi and Wi-Fi region. And finally set the locale information. Then hit save and then write. Once this is done, eject the card from your computer, place it in the Raspberry Pi, and power it up. All right, so now we've got the TV back on the wall. Everything's connected, powered up. So let's jump into the Raspberry Pi and configure Hyperion for this project. So the first change we need to make is we need to change how Hyperion runs. If you use the flashable image, Hyperion's going to run as Pi. Now, to access some of the pins on the Raspberry Pi, it needs to run as root. So we need to make a quick change by SSHing into the device. Now, to do that, obviously open up your favorite terminal program. I use Terminus. You can use Putty, whatever you happen to want to use, but go ahead and connect in to your Raspberry Pi. So if you followed my instructions from before, we did set up SSH by default. So if you haven't done that, then you'll need to set up SSH so that way you can make changes to the device using terminal. I'm gonna go ahead and SSH into my device. Now that we're connected into terminal, let's go ahead and confirm which user that Hyperion is running as. So we're gonna go sudo system control status Hyperion. You can usually type in the first few letters and then hit tab. So you'll notice it says Hyperion at pi.service, which means that Hyperion is currently running as the Pi user instead of as the root user. So to fix this, we'll hit Control-C to go back out into command prompt. We're gonna use the command sudo. So we're gonna run sudo system control disable -- now Hyperion at pi.service. So what that's gonna do is it's gonna remove the systemd command that will automatically start the Hyperion service. So then we can just hit up to bring up the same command again. We're gonna change pi to root, and then we're gonna change disable to enable. So the total command is sudo system control enable -- now Hyperion at root.service. So this will allow us to run the service as root, so we have access to the PWM pin. There are two methods for controlling the WS2812B lights. One is using PWM, which is what I'm using today, and the other is using the SPI or SPI bus. I think the SPI bus on my Raspberry Pi might be damaged because I did use it on my Octoprint instance and I had problems with lights on it. So that's why I'm using the PWM, and that's what the full instructions I'm doing today are for the PWM. So now that we've got it re-enabled, let's go ahead and make sure it's running. So sudo system control status Hyperion. So it says it's running as root and it's been started. So we'll go ahead and click into our browser. So we're going to go to the IP address of our Hyperion running Raspberry Pi. It's going to be the IP address of the Pi :8090. So 8090 is the port used for the web interface for Hyperion. So this is something you're going to need to remember because we're going to use it quite often. So once we're into the dashboard, you might get a little pop-up saying, hey, you're using the default username and password. If you want to, go ahead and change it to a different username and password, but I'm not really going to worry about it right now. So first thing we need to set up is our LED instance. So we'll go to LED instances and LED output. And under LED controller, we're going to change controller type to the RPI PWM for the WS281X. So you can leave the maximum LED count the way it is. The GPIO number is GPIO 18. You can leave the rest of these the same. Only thing you're going to need to change is the hardware LED count. So in my case, I have 220. I calculated this by just literally counting around the outside edges. Now you're going to need to do that because we need to know how many pixels are per side of the TV. So in my case, I've got 39 on the left and right. I've got 70 on the top and I've got 72 on the bottom. So the grand total is 220. So go ahead and click Save Settings. Now it's going to tell you, hey, your LED layout does not match. You haven't set up the LED layout, so you only have one available. So 219 of the LEDs are going to stay black, which is fine. We'll continue because we're going to do that in the next step. So the last setting we need to change for the LED output is the input position. So what the input position does is tell Hyperion at which point does your first LED start in relation to the TV. So if we click the LED numbers here, we'll notice that Hyperion is assuming the top left-hand corner is where our first LED starts. But in my case, it's in the bottom right. So all we have to do to get that is to add the number of LEDs across the top to the LEDs down the side, which in my case is 109. So I go to here and type in 109. Now, if you look, it's showing the LED strip starting across the bottom instead of going up the side. So then I need to click reverse direction. And now the 0 LED is the first one here, and then it proceeds up the right side as it is on the TV. This is important because if you don't set the setting, then your picture will be flipped top to bottom. So now we go to LED layout. We're going to select classic LED layout and we're going to put in those numbers I talked about. Now for reference, this is looking at your TV. So left is the left side of the TV, looking at it, not flipped around backwards as you're looking at the LEDs when it's laying down working on it. You need to flip it around to the front, and that's what you're looking at. So again, mine are even. Most people are going to have even left and right, but if you happen to have an odd number, then you make sure you know which side's which. So in this case, it's going to be the top's going to be 70, the bottom's going to be 72, left's going to be 39, right is 39. If you happen to have any gaps around the outside edge, you can add those in here as well. Mine's continuous, so I don't have to worry about that. And then I can click Save Layout. All right, what that's going to do is go ahead and get everything set up for our Hyperion instance. So if we go down to Effects, so if you want to load an effect, let's do the default atomic swirl. Hit Load Effect, scroll down here and click Continuous Test. Behind me, you'll see it's yellow. And if we were to click on this little icon on the top right-hand corner, it's going to show us what we're expecting to see here. So if we look, there's a little crawl going on the outside edge and it matches here on screen. So we know everything seems to be looking good with our configuration. So now the second half of this is let's go ahead and get the capture hardware set up. So we need to go over to capturing hardware. And now since we're using a USB device, we need to take the USB device and it's going to look out there and try to find a device. So if it shows up right here, the UVC camera, so it's going to show up as a camera. Now, one quick tip is if you happen to have issues where this doesn't show up, I've left a section in the blog post talking about how to make sure it loads the correct drivers. So you'll need to do another. So if you watched my SDR video, in Linux, you can set rules to where you have certain drivers that are loaded and not loaded. So if you do run into problems, I do have a troubleshooting section on the blog post where you can go through and set the correct drivers. But mine's being detected. So because I'm splitting off a 1080p signal, I'm going to go ahead and set the device resolution to 1080. And I'm going to set my frames per second at 30. Now, if you start noticing lagging where the input on the screen comes up much faster than the lights in the background, you might try dropping the resolution down. That might help, or reducing the frame rate. You can also overclock your Raspberry Pi and increase the processing power. So now that those things are configured, let's go ahead and fire up the Xbox and make sure everything's working. So to see your live video, you can click over here and check and make sure the colors are showing correctly. Now my colors are showing backwards right now. So I'm seeing green traces on the wall, but in the Hyperion app, it's showing red. So that means that my colors are inverted. So if I go up here to the top, I can click RGB byte order wizard, click continue, and it's going to flash. So if you look on the screen, it's red, but behind me it's green. So that's telling me that the colors are inverted. So once you do that, it should set your Hyperion to the correct color input. and then you should be good to go. So now everything is configured, Hyperion is functional, and we're getting the input coming from the Xbox being turned into the LED output going around the outside of the TV. Now real quickly, let's talk about what Hyperion can do. So in general, the main purpose of Hyperion is to do exactly what that is doing, where it's taking the input, it's pushing the output. But you can also use Hyperion to take inputs from other devices. So you can actually install Hyperion on a Windows desktop and then forward that information from your Windows desktop onto another machine or another device, and then having it to control the lights. So for example, I could have this computer forward its video input to that TV if I wanted to, say if it was hooked up via HDMI cable, or you can do those different effects. You can kick those effects off. So Hyperion primarily is used for the Ambilight. So I'm not going to really dig through all the other settings because our primary focus was just to get the Ambilight working, which it is right now. But the next section, I'm going to really quickly show you how to set up your Hyperion instance in Home Assistant. So that way you can turn on and off Home Assistant and control some of the Hyperion functions from within your Home Assistant instance. All right, so here we are in my test environment. Real quickly, I'll show you how to get the Hyperion control added in there. So the first thing we need to do is go down to Configuration, Integrations, and typically you will see it pop up here at the top. As you can see right here, Hyperion has been automatically detected. If you don't, you can click Add Integration and search for Hyperion. But I'll go ahead and do it from right here because it was discovered. Click Configure. Confirm you've got the correct IP address and port. Click Submit, and then you can assign it to an area. Click Finish. Now we're going to click on here. So if you wanted to, you could give this another name. So if you have more than one Hyperion instance like I do, you click Menu and you can go to Rename and name it Office or whatever it happens to be. So click on the device, first LED, and you'll notice right here, you have a camera image that shows you what's happening on the screen, like right behind me. So for example, it's a little bit delayed, but you can actually see what's happening on the screen in a small low-res camera image on here. So that's kind of cool. This is actually showing you what Hyperion is seeing. And then you have the option right here to enable or disable. So if I click off, the lights will turn off behind me or turn them back on again. Now, there's also a whole series of other devices that are disabled by default, which allows you a little bit more control. So if you wanted to granularly control devices like the USB capture, like these switches that are here on the dashboard, you can actually enable these, and then after a few minutes, they'll refresh and turn on. So if you cared about those particular things, you wanted to turn them on and off, you could disable or enable those. But for me, I'm just going to really use the light switch, which will just show me what the instance is set for. And then I can change down here the effect. So I can change this. Right now it's on USB capture. So again, it's going to capture back there. If I wanted to switch it back over to the atomic swirl, it would change it. And now if we look in the background, right here, it's doing the atomic swirl in the background. Or I could change it to any other effect I wanted to. So there's the rainbow swirl right there. So the nice thing about this is that you have some degree of control, not as much as say a WLED install, but you do have a degree of control. You can customize the lighting, you can customize the effects, you can change it to whatever you happen to want to do right from Home Assistant. You don't even need to go into Hyperion again. So to set this back, all you gotta do is click on the effects and go back to USB capture. And now you see it's mimicking what's going on in Halo right now. So there you go. Now you've got a fully functional Hyperion setup. So you can now spruce up your cinema room, your bedroom, or wherever else you want in your house. Hopefully this was helpful. I know I've seen a couple of people do videos on this particular one, but this was a project that I wanted to tackle this week. And this gives you hopefully something to work on over the long Christmas break. If you have any comments or feedback or questions, feel free to leave them in below or join us on our Discord server. All right, so I know this was a long one, but I appreciate you sticking with me. And if you'd like to see some other projects, you can click on this playlist here. And if you haven't already, please make sure you subscribe to the channel by clicking our logo right here. Thanks again, and have a great rest of your week.